Roof crafters set a pack of shingles with a mass of 113 kilograms on a roof. The roof is inclined at 35 degrees above the horizontal. The end of the roof is at 3 meters above the ground. The coefficient of kinetic friction between the roof and the pack of shingles is 0.4. The pack of shingles starts to slide. What is the magnitude of the acceleration of the pack of shingles? So I set up my picture along with a forced body diagram labeling my X and Y axis. So I have let me grab a pointer. I have a normal force pushing up and force of gravity, which is mass times gravity. And right here I have a force of kinetic friction sliding this way. Well, the kinetic friction is pulling this way, but the pack of shingles is sliding this way off the roof. And the roof is 3 meters above ground, the edge of the roof. So what I did was I went ahead and wrote down mass of the shingles is 113 kilograms, and the coefficient of kinetic friction is 0.4. So I know that the force of kinetic, the kinetic force is the coefficient of kinetic times the normal force. So what I did was I wrote F net equals the force of kinetic plus the force of gravity in the x direction. Then what I did was I substituted force of kinetic with the coefficient of kinetic times the normal force. And then I add mass of gravity sine theta, because that's for the x direction. Then I take F net equals coefficient of kinetic friction times mass times gravity, cosine theta plus mass of gravity sine theta. So my F net equals mass times gravity times coefficient of kinetic friction cosine theta plus sine theta. So what I did here was substitute mg. So I plugged in what I knew, and it gave me my net force of 998.03 newtons. And I came over here to my acceleration formula, which A equals F net over mass, and I plugged in 998.03 newtons divided by 113 kilograms, and that gave me 8.83 meters per second squared. That's Newton's second law. It's kind of similar to the assessment that we had in class, but changed up some numbers, and I want to figure out if anything changes besides the force of kinetic friction in this formula, because now the force of kinetic friction is going in the positive direction, so it doesn't require that negative. But I wanted to pick a similar problem because I wanted to see if any other steps also changed. Tell me what you think.